In this video, we will start with the fifth chapter in Science 1, that is acid, bases and salts. Now you have already learned some things about acid, bases and salts. Do you remember? You have studied in 8th standard. Let's revise that first. So acids are the chemical agents that release hydrogen ion when it is added to water. So that means H plus ions are released when acids are added to water. So in the form, whenever you will add, for example, you are adding hydrochloric acid with water, you will get what? You will get H plus ions there. So this is that H plus ions are released in acid. Also, the taste of acid, if you will see, so they are sour to taste. For example, if you will taste lemon juice, so it is sour to taste. Tamarind is sour to taste. So they have acids in them and that is why the taste is sour. Also, they change the color of blue litmus paper to red. So whenever you will use a blue litmus paper and you will dip it in acid, the color will change to red. So blue litmus paper turns red for acids. Next is base. Now a base is a substance that accepts hydrogen ions from another substance. So here the hydrogen ion is accepted, that is H plus ions are accepted and from the substance from which it is released. So this is called as a base. Property of base, so they are bitter to taste. When you will taste a base, you will find that they are bitter. And also the color, if you will dip a red litmus paper and you will dip it in a base, then the color changes to blue. So here the red litmus turns blue in base. So here if you will see, HCl is an acid. When we dissolve it in water, we get H plus and Cl minus. These both are separated. Next is NaOH, which is a base. When it is dissolved in water, we get Na plus and OH minus. NaCl, which is a salt. When you dissolve in water, Na gets separated and Cl minus gets separated. Let's understand about the ionic compounds. Now we all know that whenever a molecule of ionic compound, there are always two constituents, that is cation is there which is positive and anion is there which is negative. Now these cations and anions, they are attracted together and they are attracted by a force of attraction that is called as the ionic bond between the oppositively charged particles. So here if you will see, it is Na, that is sodium, and here if you will see, it is chlorine. So now when these two combines, we get NaCl. So what happens is one is a cation, one is a anion. Now here if you will see the electronic configuration which is there, here if you will see in the first shell it is 2, in the second shell it is 8 and in the third shell only one electron is there. In chlorine, if you will see, in the first shell we have 2, in the second shell we have 8 and in the third shell we have 7. So here one electron is more and here one electron is less. So what happens is, here the ionic compound are formed, the ionic bond is formed between these two, that is Na and chlorine. So this one electron is shared with this chlorine atom. So here it becomes 2, 8, this becomes stable and it becomes positive and becomes a cation. And this, as it is taking the anion from someone else, it is taking the electron from someone else, so this becomes an anion and it acquires a negative charge, and this is how these both are attached together with the ionic bond. So the formation of compound NaCl takes place. Here you will see, like Na is there, it will lose one electron and it will become positive, that is Na plus. From 2, 8, 1 it becomes 2, 8. Cl, which is 2, 8, 7, it is having one less electron. So this electron which is lost, it is received by this and it becomes complete. It completes its octet and it becomes the negative ion, that is anion. So when these two combine, that is NaCl, when it combines with Na when it combines with Cl, we get NaCl and the electronic configuration becomes of Cl becomes 2, 8, 8. So here is our ionic bond which is formed between the electrons by sharing and giving of electrons, and such compounds which are formed by an ionic bond, it is called as the ionic compounds. Let's now understand the dissociation of ionic compound, how these ionic compounds can be separated. Like for example, NaCl that was formed, how it can be separated. Now if here you will see the NaCl which is there, which is salt. Now if we will see the compounds which are there in NaCl, so all these compounds are sitting side by side. These all, that is Na and Cl, are both attracted to each other and it is in solid form. But as soon as we dissolve it in water from solid form, what happens is when you dissolve it in water, water try to push itself between these bonds, and because of which these bonds break, and the solution that we get, it is an aqueous solution. So if you will see, Cl is separated and it is surrounded by water. The Na is separated and it is surrounded by water. So all the compounds, all the molecules of Na and Cl, they break and the water is pushed into it. This is called as the formation of aqueous solution, or you can say dissociation of the salt in the aqueous solution. Now a scientist named Arrhenius, he put forth his theory on acid and bases. So according to him, acids are the substances which produce H plus ions in the solution. So whenever we dissolve an acid in the solution, they will be producing H plus ions. And bases are the substance which produces hydroxide ions, that is nothing but the OH minus ions. So here we get the H plus ions in acids, and in OH, when you dissolve in water, you get OH minus ions. So this was the theory which was put up by Arrhenius. So for example, an acid, that is HCl, if you will dissolve it in water, you will get H plus plus Cl minus. And if you will take a base, that is NaOH, and if you will dissolve it in water, you will get Na plus plus OH minus. So this is what the theory, that H plus is produced and OH minus is produced in base. Now there is one more thing, that neutralization happens because of the hydrogen ion and the hydroxide ion. Now about the neutralization you will be learning in the further video, that is how the water is produced because of neutralization. So here is the example of the Arrhenius theory, that is HCl, when it dissolved in water, we got H plus and Cl minus. And when we take a base, that is NaOH, when we dissolve it in water, we get Na plus, and this is, that is OH minus. Now acid and bases can be classified as strong acid, weak acid, strong base and a weak base. Now what is a strong acid? So strong acid is when you dissolve it in water. So we get the main constituent is H plus ions and the concentrated acidic radical. That is, if you will see HCl, so if you will dissolve it in water, we get H plus plus Cl minus. So here we get more number of H plus ions. Weak acid, when we dissolve a weak acid in water, we get less number of H plus ions in the solution, and the concentrated acidic radical is in small proportion because of the less number of H plus ions, and large number is the undissociated molecule. Now here if you will see CH3COOH, when we dissolve this in water, we get H plus and then we get CH3COO minus. So that means that only one H is dissociated and most of the hydrogen is not dissociated. So we get very less number of hydrogen ion. The same happens with the strong base as well. On dissolving here, if it is a strong base, so the main constituent that will be only OH minus ions. And if it is a weak base, then we will get small proportion of OH minus ions and the more proportion of undissociated molecule. So these are called as a strong acid, weak acid, strong base and a weak base. Now there is also alkali. So these are highly soluble in water. So that is why they are called as alkali. And if they are, alkalis are very much strong, and if they are weak, for example, NH3 is a weak alkali. So we also have strong alkalis and weak alkalis. So if they are readily soluble in the water, then they are called as strong alkali. Next, we have the basicity and acidity. Now, basicity of an acid and acidity of bases. So, basicity is nothing but, for example, we are dissolving an acid in water. That means we are dissociating the acid. So, what happens is the H plus ions which are obtained from one molecule of an acid is called its basicity. So, the number, for example, HCl, so you will get one number of, that is 1 H plus ions can be obtained. If it is H2SO4, we get 2 H plus ions. So this is called as the basicity of acid. Next is acidity of bases. So this is the number of OH minus ions which are obtained by the dissociation of one molecule of base. So for example, if it is NaOH, so when you dissociate in water, we get OH and Na. So this OH, that is one OH that we got, that is called as the acidity of bases. Now let's learn about concentration of acid and bases. Now here we have taken lemon juice and we have taken two beakers, that is beaker A and beaker B. Now in the first beaker, that is beaker A, we have added 1 teaspoon of lemon juice, and even in beaker B we have added 1 teaspoon of lemon juice. In beaker A we have added 10 ml of water, and in beaker B we have added 20 ml of water. So now what happens is, in this activity, the sour taste of the solution is because of the solute, that is the lemon juice. So lemon juice is the solute. Now the quantity of lemon juice is same in both the solution. In both A also we have added same amount of lemon juice, and in B also we have added same amount of lemon juice. The quantity of solute is same, but here what is different is the solvent, that is the water is the solvent, and that is different. So the ratio of quantity of solute to the quantity of the solution is different. This ratio is larger for the solution in the first beaker, and if you will see, for that is the reason why the first beaker tastes more sour, and the proportion of lemon juice is less in the second beaker, so that is why it doesn't taste that sour as it tastes for the beaker 1. So the taste of foodstuff depends upon the nature of taste, giving the ingredient and the proportion of the foodstuff. So here also the properties of a solution depend on the nature of the solute and the solvent, whether it is more sour or it is less sour. So it both depends on the solute and the solvent, the amount of solute and solvent, and the nature of solute and solvent. So the proportion of solute in a solution is called the concentration of solute in a solution, and it becomes the concentration of acid and bases. For both acid and bases, the same manner we can find whether it is more concentrated or it is a dilute solution. Next is pH. Now usually we have three types of pH, that is acidic, basic and neutral. Now pH of solution is determined by the number of hydrogen ions which are concentrated in that solution, and it expresses whether it is having acidity or it is basic or it is neutral. Now you may think, what is pH? So pH is nothing but the power of hydrogen. The pH scale extends from 0 to 14, and according to the scale, pure water, if we will take, it has the pH 7, meaning that pure water has H plus, that is 1 into 10 raised to minus 7 mole per liter H plus ions, and the pH 7 indicates that it is neutral, and that is why we can consume it easily. Now the pH is the midpoint of the scale. The 7, that is the midpoint of the scale, and all the things which has the midpoint, that is 7 and nearby, those are considered as neutral, and if they are little above the neutral, then they are considered as weak acid, and if below, they are considered as weak bases. And on the top, if the pH value is 0, 1, 2, 3, they are considered as strong acid, and if the base value is 11, 12, 13, 14, they are considered as the strong bases. So here in the table, you can identify that there are different substances which are given, and according to the substances, according to the pH, we determine whether it is strong acid, whether it is a weak base, it is neutral, or it is a strong base. So now we know that in the pH scale, the pH of solution varies from 0 to 14, and it is according to the strength of the acid or base. Now to show these variation in pH, a universal indicator is used. So a universal indicator shows different colors at different values of pH. A universal indicator is made by mixing several synthetic indicators in specific proportion. So the pH of a solution can be determined by the means of universal indicator or the pH paper from which it is made up of. Now, the most accurate method to measure the pH of solution is to use an electrical instrument called as the pH meter. And in this method, the pH which is measured by dipping the electrodes in the solution. So here also in the picture you can see that two electrodes are there and the solution is there in which it is dipped and the pH is given. So it is the most accurate method. We can even find the pH through pH papers or by using universal indicators.